Alright, so today we're going to be doing 610, which is going to be rational exponents. So rational exponent is a fractional exponent that can be expressed as an nth root. So it's another way of expressing a root. So you can always convert back and forth as needed. So basically, if you're taking the nth root of x to the a, that's the same thing as x to the a over n. So whatever the exponent is on your radicand over the index, okay? So just some important things to know. Basically, when you are multiplying two of the same base terms together and they have different exponents, you would add those exponents together. When you are dividing same base with different exponents, you subtract them. And when you're doing a power to another power, that's where you multiply. So you want to look at these examples to help guide you with what operation you're going to have to use. We covered this in lesson 1.4. So if you want to look back to those notes, that can help. So the main idea is, unless otherwise stated in the directions, you're going to end with whatever method you started with, or whatever form that you started with, okay? So we're going to go ahead and start. We're going to do 1 and 4 first because they're pretty easy, and then we'll move on to 2 and 5. So the question here, it asks us to express them in the opposite way that they are not expressed. So in this case, we're already a fraction, so we want to convert it to a radical. So you write a radical, and then inside you're going to put whatever your base is, in x in this case, to the power of the numerator, and then the denominator is going to be the index of your root. Okay. Now we also need to be able to go the other way around. So that's going to be b to the what power? 3 over 5. Good. So see how they convert both ways? Everyone good with that part? All right. So 2 is a little bit tricky. I don't want you to be discouraged by it. This is actually a negative 4/5. So anytime you have a negative exponent, I want you to bring it down to the denominator of your fraction, okay? Because that's how you make an exponent positive, is by bringing it down to the denominator. Or if it were in the denominator negative, bring it to the numerator to make it positive, okay? So the negative or bad thing about this is you cannot have fractional exponents in the denominator as well as roots. So here's the way we get rid of it. Let's think carefully here. Something we can multiply this y to the 4/5 by, that's going to get it to have an exponent of 1. So let's think about it for a second. I'm going to put this to some power, so I'm not multiplying by just y. If I think of how we deal with exponents that have the same base, we want to figure out what this exponent has to be to make this 1, right? So if I take 4/5 and I add it to some number, I want that to come out to be 1, because that's how you deal with exponents. You add them together, okay, when you're multiplying. So any ideas on what I can add to 4/5 to get me to 1?
1/5.
1/5. So we need to multiply the top and bottom by 1/5. Okay, so let's go ahead and do that. So everybody has their notes out and is taking their notes here? Okay. So we have y to the 1/5 over, and here we're going to add these exponents. So when you multiply two common bases, you add the exponents. What's 4/5 plus 1/5?
1.
Good. So you just have this, and then we have to convert it into a root. So in the top, what's the top going to look like as a root? It's going to be a 5 on the outside and a power of 1 on the inside. And that's our final answer. Okay? Any questions about that? Samira, you have your notes out? You don't have the notes. Do you need a copy of them? So hang on. Let's go ahead and do number 5. So for number 5, as you can see, the power is on the outside. Okay? So let's go ahead and look at this. So this is going to be the 4th root of c times the 4th root of c times the 4th root of c. because we're doing it to the third power. Everyone understand why we had to write it out 3 times? Okay. So, what is c times c times c? C cubed. So see how it's the same thing if the exponent's on the inside or the outside?
Oh, yeah.
Makes sense? So, now we can convert it into an exponent. So this is going to be c to the what? 3 over? Good. Make sense? Okay. All right. What's the implied exponent on the a?
1.
So this is going to be a to the power of?
1 over 5.
1 over 5. Good. Any questions on that one? So how are we going to have to rewrite this one because it's negative? 1 over this, right? And now we can rewrite it in the form of a radical, 1 over the third root of 64. What is the third root of 64?
4.
Where was the negative?
It's like right here. You can't see it?
No, I can't. Okay, great. Thank you.
It is a little hard to see. I think it might be easier to see on your paper. I don't know. Maybe not?
Yes, it
Okay.
is.
Because, yeah, on here, for some reason, when it blew up, it, like, merged together a little bit. But, yeah. So any questions about that? Okay. That's because the perfect third root of 64 is 4. Okay, because 4 times 4 times 4. All right, moving on. Now we're going to go ahead and simplify.
What are we supposed to turn into a radical?
Not in this case because everything's simplified out of the radicals.
Alright.
Okay. So this one here, we're going to go ahead and convert each of these to fractional exponents, okay? So with a regular square root, the index is 2 and the exponent is 1, so that's going to be 3 to the 1 over 2. Good. And here this is going to be 3 over what? Or to the 1 over 4. Good. This is product, multiplication. What do we do with the exponents when we're doing multiplication? Good, you add them. Very good. So we got to add these together. Anyone know what 1/2 plus 1/4 is?
3/4.
3/4. And if you need to, that one's easy to do in your head, but if you need to, you can use a common denominator. Now we got to convert this back into root form. So what's the root going to look like?
4 and
3 to the third. Which is really the fourth root of what? 27. Any questions about that one?
Wait, so how'd you get 27? 50 times 3 is 9.
3, and then times 3 again is 27.
Okay.
Alright, this one here, it's easiest just to know, I'll just tell you, that 2.5 is negative 5 over 2. So it's just 5 over 2. That's its fraction equivalent. I'm just going to tell you that. So, since it's negative, what do we have to do?
We have to like swap over 1 under 1.
Yeah, under 1, exactly.
Yeah, sorry.
That's okay. And now it's going to become 1 over the what root of what? The fifth.
The
6 to the 5th. Everyone understand how that worked out? Okay.
Yeah.
So here's the thing. We learned up here that you can take the exponent and bring it to the outside or vice versa. Everyone see in number 5 how we did that? Exponent can go inside or outside. Let's look at this for a second because I think that it might actually be beneficial for us to put the exponent on the outside. Everyone see why that might help us here? What do we know about 16 if we're taking the square root of it?
Oh, it's a perfect square, so then you could do that and then do it to the power of 5.
Exactly.
That makes so much more sense.
Isn't that so much easier than doing 16 to the 5th power first and then breaking all that down? That's like a million. That's literally going to take you like a whole page of paper to do. So work smarter, not harder, okay? That's going to be 1 over 1,024. So if you do 4 to the 5th power in the calculator, that's what you get. Make sense?
Yeah.
Okay. So this one's gonna do the same thing. So this one comes out to be the 5th root of negative 32 to the 4th. Now here's where you have to be careful. See how I put the negative number into parentheses?
Yeah.
I did that because when it's negative, we have to make sure that negative is also to the power because it will change the sign, okay? So here's the thing. I'm going to rewrite this one like this. Everyone see what I did there? I took the power out to the outside, which you're able to do. And there's a reason I did that. Because negative 32 is a perfect 5th root. So there's some number that you can multiply together 5 times that will get you to negative 32. Any ideas?
2.
Not 2, but you're close.
3.
Not like that. Negative 2.
Oh.
Close enough.
And then we have to apply the 4th power. So my final answer is
32. Oh.
16.
16.
Because then, since it's by an even number, the negative cancels out.
Even number to an even power becomes positive. Even number to an odd, negative number to an odd power stays negative. Make sense? Okay. So this one, we have 2 radical expressions that we're going to each rewrite as fractional exponents. Everyone with me on that step?
Why can't you just like write? Why can you write them like fractional?
Because radicals are, in essence, actually just fractional exponents.
Oh, okay.
Yeah, there's a whole thing behind it, but yeah, basically we use radicals to easily simplify what is a fractional exponent.
Oh yeah, because radicals are super simple.
Yes. Well, they reverse each other, so that's why it works in a way. So what can we do with that denominator, with that fraction in the denominator?
You can divide it by 2.
Yeah, to reduce it, right? And
so you get like 1/4.
1/4. And if you look at the front of your notes with all the rules, it states that with division of the same base, what can you do with the exponents?
Subtract them.
Subtract them, right? So what is a third minus what is 3/4 minus 1/4? 1/2, aka, well, 2 over 4, which is 1/2. But the answer has to be written in radical form. So that's 2x to the first, which more simply is just the square root of x, right? So everyone able to follow those steps? So anything to the 1/2 power is the same thing as the square root of that thing. And that's why squaring a square root cancels it out, because you're basically multiplying 1/2 times 2, which is just 1. So that's the reason it all works out. So let's go ahead and try number 11. 11 is very similar. What is the top exponent going to be? 3 over 2. Remember, this is always a 2.
Oh, 2, yeah.
And then the bottom's going to be?
2 over 3.
Good. That's the same thing as if I wanted to subtract those exponents. But we have a problem here because we're missing a common
Denominator.
Good. So I'm going to just leave the x here for now and just do the fractions with the common denominator. If I'm doing this minus this, I need to find a common denominator. What is it going to be here?
6.
Good. So I'm going to multiply the top and bottom by 3. And here I'm going to multiply top and bottom by 2, which gives me 9 over 6,
and 4 over 6.
which simplifies to
5 over 6.
good.
Apparently I can't add.
No, that's alright. I mean,
You subtract, whatever we're doing.
so this is x to that power, right? So how do I have to rewrite it?
You do x, well,
Mhm.
you have to put, you put x inside the 6 on the outside and the 5 on the inside.
Good. Any questions about that one? Okay. So this one's a little bit more tricky, and this is because we're mixing together roots and radical exponents all together. So when I deal with something like this, I like to divide everything up separately because I find it to be easier. So basically, I'm going to do the -8 to the power of 2/3 times x to the power of 2/3 times the square root of xy to the power of 2/3. So everyone see what I did there? I just separated them out into each individual multiplication. Now here, when you're dealing with a number, it's typically easier to have it in radical form to simplify. So I'm just rewriting this into the form of a radical. This is just going to stay as it is. And then here, I'm going to convert what's on the inside into an exponent. So if something is a square root, this means they both have a power of 1 and an index of 2. So what power are they each to? Power of 1/2, right? You see how I just converted it into the exponent. Now, I'm going to go ahead and simplify this. What's -8 to the second power? 64. This is going to stay as it is. And then here, I have the power to power rule. The power to power, yeah, what did you say it was going to be?
You would have to do a common denominator. No.
Mhm.
Power to power rule, which is multiplication.
Good. What's 2 times 1? Good. And 3 times 2?
6
But I can reduce that fraction, right?
to 1/3.
1/3. So this is all to the power of 1/3. Now, what is the third root of 64?
4.
4. This stays the way it is. And this, I can apply that 1/3 to each one. You see? Now, these are the same base, so I can add their exponents. What's 2/3 plus 1/3?
1.
1, so just x to the first, y to the 1/3. That's my final answer.
You went way too fast.
Did I? Sorry, I was trying to go really slow. So to reiterate what happened here, I rewrote each of these individual numbers expressions to the power of 2/3. I rewrote the numerical one in the form of a radical to be able to simplify. I squared the inside and then took the root, which was a perfect root. Here, I changed the radical into an exponential fraction, and then I multiplied because this is the power rule. Once I saw that x times y was to the power of 1/3, I separated them into 2 individual terms, which each have the power of 1/3. Yes?
I have a question, just to make sure. When do you use the power rule again?
Power rule is only used when you have some variable or number to a power, and then it's put to another power. You can differentiate the difference between power rule and multiplication rule, because with multiplication rule, you're going to have 2 of those things. With power rule, you only have 1 of them.
Okay.
You see?
Yeah.
All right, so